So today we will deal with a problem. It will be problem 28. I mean, chapter 28 from Halliday and Resnick, and we're going to deal with problem number 6. Okay, so it's a simple problem that we can think a little bit about it. And as you can see here, it's a proton moves through a uniform magnet field given by B 10y minus 20j directions, right? 30k milliteslas. At time t1, the proton has a velocity given by this vector here, this velocity vector. You can see that we don't have Vx or Vy, but we do have Vz. And in the magnet force on the proton is Fp, and we just have the y, I mean the x and y components of this vector. That means the z component doesn't exist, or you can consider 0. So the question is, at that instant, what are Vx and Vy? So as a summary, I wrote down here the data, everything that the problem gave us. So if you can read my handwriting, so this is going to be my magnet vector, my velocity, and the force. Okay, and here's something that is good to remember. As you can see, we have here 1 Tesla, it's equal to 1 Newton divided by ampere times meter. And 1 ampere, it's equal to 1 coulomb per second. So this is really good to remember. Now, you're going to see why I wrote this matrix here, okay, in a few minutes. Count down. So let's start to working on this project. I mean, on this problem here. By the way, let me add something else here, that our charge, I mean the proton, so it's gonna be our positive here, right? So it's gonna be positive, will be 1.602 times 10 minus 19 coulombs. Okay, so this is our charge. Okay, so we're gonna have to use, we're gonna need to write down here because we will use in some point. So don't forget, we have this guy here. Okay, you see that my skills in OneNote, they are improving, and I will really become a YouTuber soon. So take a look here, guys. So the first thing that we need to remember, what is the formula that we will use for this problem here? So the formula that we're going to use will be our formula of the force, the magnet force. That means the charge times the velocity vector cross product with our magnet vector. So this will be our equation 1. Okay, so this will be our equation 1. So guys, when you see this function here, when you see that the force due to a charge, and this force, it can be understood as a cross product between the velocity and the magnet field. We always remember our right hand rule, right? But math people will think every time when they see a cross product here, what they think, it's a matrix. The first thing that they think about it, it's a matrix, and how we can organize this matrix here. So as you can see, I organize it here in like a generic vector A cross product with a generic vector B. And we have our 3 components here up. And we have AX, AY, AZ, BX, BY, BZ. It's clearly what we have for velocity and magnet field, right? So how will we do this one here? So I will show you how I do, and you can do, I mean, you can do whatever you want, but the way that I think about this guy is, okay, if I need to start with my y component, my I component, my x, right? So what I do is, okay, so I will think about this guy. So I will cross this one, I will cross this one, and I will start to working on like, okay, so I will have AY and BZ. Can you see that? AY and BZ. So AY times BZ. And I always needs to remember that here it's plus, minus, and plus. This will help me a lot because now I'm dealing with the plus, right? Okay, so AY, BZ minus AZ, right? Times what? BY. Okay, so I did this, and then minus I did this. And all this guy will be my y component. So I will do this direction here. I will not put everything together into just one line because this can be worse, okay? So now what I'm gonna do is, okay, so now I will do with my j component or my y component, right? So what I do, I cross this guy and I cross this guy, and now the only thing that I need to handle is, okay, it will be my, let me get here, color. Okay, so now I will handle with my j component. But remember, the j component has a negative sign here. So I have negative, and then ax times bz, ax times bz. And then now negative, right? Because it's minus az times bx. So az, whoop, az, my a is horrible, so I will redo this guy here. Az, whoop, let me get here. Az, now, okay, x and bz. Am I right? Or no, it's azbx. You see? So it's gonna be azbx. Okay, and this will be my j component. Agreed? Now I need to deal with the z component, right? The q component. So okay, so I just need to handle now is, well, I will cross this guy, right? And I will handle only with those that we are missing right now. So I will deal with, so remember, this is positive, plus, minus, positive. So now I have positive here, and what I'm going to have will be ax by minus ay bx. And that will be my k component. Okay, so we have the matrix now. So, and we can apply this one here, whatever we want. Okay, so this will be good for us to just save here in this place. Okay, so if I have my v component and my x and my b component here of my vector, I can apply the same rule, the same math that I use to calculate my cross product between a and b, and I can figure out everything, right? So, okay, so if I have this guy here, I can link it to this equation, to equation number 1, okay? So I will make a link now between these guys, my result from the matrix, to the equation number 1. But for that, what I need to remember is the force here, it has components y, j, and k as well. So how we can write this one here. So the way that we can write is, okay, so F will be fx y plus fy j, okay, plus fz k component. Do you agree? It's the same thing that this vector magnet force here. And I will just keep going with the equation, okay? Q, that means my charge, a positive charge here. So I will write down my positive charge here. And now what I can do, to be honest, I just need to write down my matrix here. So Y, right? Y component, J component, and K component here, right? And I can write down my Vx, my Vy, my Vz, and here my Bx, By, and Bz. Agreed? So basically, we have equation 1 written in matrix way, okay? So you're going to see that this is going to save us a lot of time. And now the result of this, I can just grab these guys here and just apply who is my AY. It's going to be my VX, right? So I can rewrite everything here, okay? No problem at all. So let me rewrite here. So now what I have is my electrical charge, positive charge here, and I can put like a bracket here, and gonna be okay. So let's write Vy Bz. As you can see here, Vy B Ai Ay Bz. So here you're gonna write Vy Bz, okay, minus the same thing on the other side, Vz By, and this will be my Y component. And now the way that I can write this guy here is going to be negative, okay, Vx Bz minus Vz Bx, and this will be my J component, and at last but not least, what we're going to have, our K component. So it's going to be Vx By and minus Vy Bx. You might be thinking, why in heaven, why I'm writing my K component of the force even though I don't have a K component of the force? Well, so because of that, because we know that we don't have this component here, that means this guy here, it's equal to 0, right? It turns out that we can think about this. So let me write down something here, guys. So we are saying that Vx By minus Vy Bx, it will be equals to 0. Agreed? That means Vx By, it's equal to Vy Bx. Well, it seems that if we calculate Vx, we can automatically, we don't need to do the same work that we have been doing to calculate Vy. You know why? Because we can just apply, for example, if we calculate, because the way that I thought this problem was, I will calculate Vx, and guess what? My Vy will be just Vx times By divided by Bx. And we have those guys. We have these guys. I don't need to be concerned. I mean, Vx I will calculate, right? Vx I will calculate. And then By, I have it. Take a look. By and Bx is over here. Okay? So this will help us somehow. So now what we're going to need to do is let's calculate Vx. But to save time and to save a lot of numbers as well, if you can correlate, take a look. Your Fx here, it's this guy here. Take a look. Do you agree? Your Fy, it's whom? It's this guy here. Agree? And your Fz, guess what? It's this guy. Okay? So because of that, what I can think is, well, the one here that I have Vx and I can calculate, take a look. If I take the my Fx here, well, I don't have Vx in this equation here in part A. I don't have. In part B, I do have. C I have, but it's turned out that it's going to be equals to 0, so I will be extremely confused and problematic here because I don't have Vy as well. So the one that I need to get is going to be this part here, the part B that is linked with Fy. Agreed? Okay. So because of that, the way that I can write down this guy is, okay, so I have Fy will be equal to negative of, going to be negative of my electrical positive charge here, remember, and will be Vx, agree, Vx Bz minus Vz Vx. Agree? Both are J component, and I have this guy, right? But the thing is, I have this negative sign here that I don't like it. So what I can do, I can get this negative sign and just change position here, because this negative sign, when I multiply here inside of this parenthesis here, it will turn out that will be, okay, I still have my positive charge, and now what I have is Vz Bx negative Vx Bz. Did you notice what I did? I just put this negative sign multiplying inside of my parentheses here, and I inverted. This guy here now is positive, and this guy here now is negative. You might think, why this helped me? You're gonna see it. So now, guys, what? To be honest, the problem is over. Now it's just out. It's not even algebra. It's you just need to plug it in the numbers. Okay. So I will write the first line, and I will show you the answer. Okay, because this is just plugging in the numbers, and using your calculator. Right. Please do it step by step in your calculator. Don't put the bunch of numbers, and because you're gonna mess it up something, right? Okay, so what you have is, okay, so Fy. Who is Fy? Fy here is gonna be Fy 2.0 times 10 minus 17. So your Fy will be 2.0 times 10 minus 17 newtons, right? Equals to what? Your electrical charge. So your electrical charge will be 1.602 times 10 minus 19 coulombs. Multiply by what now? Now are those guys inside here, okay? So let me start a bracket here, and gonna be Vz. Who is your velocity in z? Velocity in z is 2.0 kilometers per second. But remember, we are using International System of Unities, okay? SI. So we need to use in meters. So because of that, what we have here for Vz times Bx will be, well, will be 2.0 times 10, 3, because K means 10, 3 meters per second. Okay, now times BZ. I'm sorry, it's VZ times BX. Who is your BX? BX is just 10, right? It's just 10 milliteslas. So what you're going to need to multiply, it's 10 times 10 minus 3 teslas. Do you remember milliteslas? 10 minus 3. Okay? And then you finish your first part. Second part, minus Vx. Who is your Vx? Your Vx, you don't have it. This is what you want to calculate. So Vx here multiplied by what? Bz. Your BZ, BZ 30, yeah, 30 milliteslas. So here you're going to have 30 times 10 minus 3 teslas. And then you can close your bracket here. Okay? So now it's just multiplications and Vx. You remember 1 Tesla means 1 Newton per ampere in meters. So your 1 ampere is 1 coulomb per second. So it's going to be coulomb on the base here on denominator. So you can just, if you apply all this units here, you're going to see that you're going to have only meters per second. So this thing here ends up as Vx. Please try to do that. Try to plug it in the numbers and try to calculate and use your algebra skills, because Vx will be equals to minus 3.49 times 10, 3 meters per second. Okay, and it is negative. Now we got Vx, right? We got Vx. Now what should we do? Well, if we got Vx, now we can apply straightforward into this equation here. We can just plug it in the numbers, and guess what, guys? We have Vy equals to Vx, so we have the number, minus 3.49 times 10, 3 meters per second, okay? Times what? By over Bx. Well, By 20, so it's going to be minus 20 milliteslas divided by 10 milliteslas, because it's going to be Bx. So it's going to be 10 millitesla. Well, we can cancel out milliteslas. This negative here will cancel this negative here. And our final answer for Vy will be 7.0 times 10, 3 meters per second. So guys, this is a basic problem that we can do it based on what we have learned so far. Okay, so this will be really useful for you guys in your work, homework and everything. Okay, so I hope you enjoyed the video, and let me know if I can help you somehow.